There is a saying in English, don't settle for what life gives you. Make life better and build something. What does it mean? It says that don't settle for what you have, do something better. Welcome back to Computer Science Data Representation class. In the last class, we have seen conversions, different types of conversions. Decimal to binary, decimal to octal, decimal to hexa. Similarly, any number system to decimal. 5-mark question can be asked something like this. To the base 16, BEAD, to the base 16 it's hexa, is how much? To the base 2 is how much? To the base 8 is how much? To the base 10. We have to convert this particular number to all other number systems. Or one more example may be asked like this: 1.1011 to the base 2 is how much? To the base 8 is how much? To the base 16. Try to work out the problems like this. Next topic will be a representation of signed numbers. Representation of the signed numbers. What does it mean? Digital computers will work on both positive and negative numbers. So far, with respect to conversions, whenever we have written a number, directly we have written the number something like this. For example, 2, 3, 5, 6 to the base 10. That's why if we write a number like this, suppose we don't write the base, of course it's understood that it is decimal number system. When we want the numbers with respect to the sign, for example, suppose we take a number, simple number we shall take 5. Also we shall write -5 plus 5. What is the meaning, or what is the difference between these? Whenever we have a positive number in day-to-day life, we will just write like this without representing the sign. But when we have to represent the negative values, we need to mention a sign, that is minus, to the left side of it. Right? So, under the topic a representation of the signed numbers, we have different divisions or subtitles. First one is sign and magnitude representation. Sign and magnitude representation. Then ones complement. Then we have twos complement. These are the different methods how we can represent signed numbers. One by one we shall see. Coming to the first one, sign and magnitude representation. representation of signed numbers is also called as fixed point representation. Now coming to the sign and magnitude representation. As we have discussed, let us recall it once again. We can write a number 5 plus 5 or minus 5. Let us recall. Suppose we talk about a switch. Let us write a switch. It's just like 5 here. Now we have to compare whether the switch is on or off. Suppose we say that switch is on, then we can write switch is on. Similarly, we can write off, switch is off. Just trying to compare it. Need not remember all these things. That is about the example. What I want to say here is, whenever we talk about a number, if we want to say what it is, for example, what the sign is, that means we need to have some extra information, right? That extra information has to be represented with respect to something, isn't it? When we talk about digital computers, we know what is the importance of binary number system. Anything that we write will be converted to the zeros and ones, isn't it? So along with the, we call it as magnitude. How much it is? It is the magnitude. This is the magnitude, this is the magnitude, and this is sign. So this will be magnitude, this will be the magnitude, and this will be sign, isn't it? Now we also know that in binary number system, how many states we have, or how many symbols we have? 2 symbols, isn't it? They are 0 and 1, isn't it? Only 2 symbols. That's why whenever we are comparing the sign, these signs, either plus or minus, if you are representing the sign numbers, I am talking about representing the sign numbers, either 0 or 1 we have to write, isn't it? Remember, this 0 we will use for positive, important for us. 0 will be used for representing the positive numbers. Similarly, 1 will be used for representing the negative numbers. Hope this is understood. We shall go to that once again. 0 is used to represent the positive numbers and 1 is used to represent the negative numbers. Don't think it's vice versa, no. 1 is for negative and 0 for positive. That means this symbol, either plus or minus, will be represented with either 0 or 1, and already we have seen LSB is there, MSB is there, isn't it? So this particular symbol will work as, or that will be written in the place of MSB. So if we write a number, for example, some number, let us write some 75. Convert that into binary. Simple method is, you can keep on dividing by 2, write the quotient and remainder, keep on dividing the quotient till the quotient becomes 0, then write all the remainders from bottom to top. Or one more method, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, etc. The values we know: 1, 2, 4, 8, 16, 32, 64, next one will be 128. This is 75. So if you write 128, this position is not required because the value is 75. 64, yeah, 60. See, easy method. This is not required 128, because if that bit becomes 1, that will be above 128. Here it is 75, so 64. 64 we need 75 minus 64 will be 1, isn't it? So this bit will be 1, that is 64. Next is 11 is required. 11 will be 8 to 10, 10 plus 1, 11. So this will be 1, this will be 1, this will be 8 to 10, 11. 11 plus 64 will be 75. So this will be 0, this will be 0, this will be 0. If you are finding this method as difficult, just keep on dividing by 2, write the quotient and remainder, keep on dividing the quotient till it becomes 0. So 1, 2, 3, 4, 5, 6, 7. One more thing, whenever we are going to represent something in computers, that will be represented with respect to byte, isn't it? In the last class, in previous classes, we have seen, in case of digits, suppose we are trying to combine together all the concepts that we have seen earlier. See, whenever we write the numbers 2, 5, 6, for example, these are all called as digits, isn't it, or symbols. But when we write a binary number, suppose we have the value 1011, here we won't call it as digit, we call it as bit, isn't it? So what's a bit? Bit can represent either 0 or 1. How many bits are there? 1, 2, 3, 4. 4 bits are there. What is the full form of bit? It is binary digit. So binary digit, B here, IT here, take it together, it is called as bit. So whenever we are representing a binary number, these are called as bits. A group of 8 bits, so group of 8 bits will be called as 1 byte. Whenever we represent something in computer memory, with respect to the bytes, we will store it. So when we take a byte, at least 1 byte we have to take at a time. So 1 byte is equal to 8 bit, right? That's why we shall take a byte. In this case, it is 1, 0, 0, 1, 0, 1, 1, 2, 3, 4, 5, 6, 7. One extra bit is required. If you consider this as 1 byte, these are all boxes representing the magnitude. So from here to here, this is called as magnitude. This is called as magnitude. Then comes, see, this is 75. What we have written is 75. This is the magnitude. Now, if we want to write plus 75, this is MSB here, this is MSB here, and this is LSB. MSB is used to represent the sign with respect to 8 bits. That's why now we are going to take plus 75. Already we have seen plus is 0, minus is 1. What we want to represent here is plus, so we will write a 0 and this is sign. The topic that we are looking at is sign and magnitude. So magnitude is what's given to us, how much it is, and then the other one is sign, whether it is plus or minus. That's why there are two types of integers. One is signed, or it need not be integers, numbers. One is signed number, the other one is unsigned number. Here we are going to talk about signed numbers. That's why when we want to represent signed number, we are talking with respect to 1 byte here, the magnitude. That's why out of 1 byte, that means out of 8 bits, we are using 7 bits to represent the magnitude and 1 bit to represent the sign. Remember, this is sign and magnitude. If you want to represent only the magnitude, then we are not representing the signed number. In that case, that will be unsigned number. Don't get confused. Once again, we shall talk about that. With respect to sign and magnitude, with respect to 1 byte, that's 8 bits, the MSB is used to represent the sign. Other 7 bits are used to represent the magnitude. So plus 75, if you want to represent plus 75, it is sign bit will be 0, that is the MSB will be 0. Remember, this is used to represent only the sign, not for the magnitude. The other 7 bits are used to represent the magnitude. What happens if it is minus 75? If it is minus 75, what is the change that we need to do here? For minus, it is 1, so that will be 1. Don't add this, once again, don't add this for the magnitude. No, this is representing the number using sign and magnitude. So this is not considered for the magnitude, this is considered only to represent the sign. We want to know whether it is positive or negative. In that case only we will be using it for sign. For minus 75, in case of sign and magnitude, this will be 1. For plus 75, the same magnitude, but the sign changes to 0. Hope this is understood. Let me clarify it once again. If we have, say, unsigned number, unsigned number. In case of unsigned number, just like our pin code, our roll number, right, our phone number, etc., etc., those are the numbers which won't have any sign. There is nothing like positive phone number and negative phone numbers, positive pin codes, negative pin codes, right? In that case, we call those numbers as unsigned numbers. Now, how it is different to sign and magnitude? In case of unsigned number, it's for your information, in case of unsigned number, suppose we have 1 byte, 8 bits we have, 8 bits we have. All 8 bits can be used to represent the magnitude because we don't have the sign. Unsigned, it's understood, it's unsigned, only positive values. If you can have only positive values, no need of representing the sign. So in this case, say, totally how many bits we have? 8 bits we have. So 2 to the power 0, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, and 2 to the power 7, starting from 0. So how much it will be? 1, anything to the power 0 will be 1, 1, 2, 4, 8, 16, 32, 64, 128. If we have one extra bit, that will be 2 to the power 8, anyhow that will be the next byte, isn't it? Double of this one, 128, 128, 256. So if you want to represent 256 255, if you want to represent 255, all the values will be 1, 1, 1, 1, 1, 1, 1 and 1. So in this case, it's unsigned number, right? So even the MSB can be used to represent the magnitude. Hope the point is clear now. Even this, we are not representing the sign. That means, in this case, see here, this is sign and magnitude. If you want to represent a sign, the MSB is used to represent the sign and it won't count for the magnitude. Right? That's why we have to take only this part. That means up to 64 only 2 to the power 6 we can have. So if you add all these values from here to here, it comes out to be 127. Right? So up to 127 we can represent using sign and magnitude. That is plus 127 to minus 127. There is a small, if you go into deeper to that, there is a small difference. Later we shall see that. But in this case, since it is unsigned number, even this MSB 1, 2, 3, 4, 5, 6, 7, 8 bits are there, no? So this is MSB. MSB is also used to represent the magnitude and there is no sign bit. That means it's positive only. It's not possible to have the negative numbers for this. But if you can have the negative numbers, then we have to go for sign and magnitude. Hope the difference between this and that is signed numbers and unsigned number is understood. Once again, in case of sign and magnitude, the MSB represents the sign followed by the group of integers is called as sign and magnitude. So MSB is used to represent the sign and other integers, other 7 positions are used to represent the magnitude. The second one is ones complement. Ones complement a representation. Any number given to us will be converted to binary. Then we have to write the number with respect to ones complement. It's easy. What's meant by ones complement representation? To make it simple, let's write like this. For example, sum 23 to the base 10. We have to write this number with respect to ones complement. So what we will do? First convert this 23 to binary. You can divide by 2 or 1, 2, 4, 8, 16. 16 plus 4 is 20, 20, 22, 23. So it will be 1, 0, 1, 1, 1. 16 plus 4 is 20, 22, 23. Isn't it? Or it will be something like this. 23 by 2. It's 11 and remainder will be 1. Again divide by 2. It is 5 and 1. Again divide by 2. It is 2 and 1. Again divide by 2. It is 1 and 0. Again divide by 2. It is 0 and 1. So it will be 1, 1, 0, 1, 1, 1. Compare, it is the same. Right? So that will be 1, 0, 1, 1, 1. This is in binary. Right? This will be in binary. What's the ones complement? After writing the number in binary, wherever there is 1, change it to 0. Wherever there is a 0, change it to 1 and 1 to 0. 0 to 1, 1 to 0. So this is 1, this becomes 0, 0 becomes 1, 1 becomes 0, 1 becomes 0, 1 becomes 0. So this is 1's complement. Write the number in binary form and change 1 to 0 and zeros to 1. Change 1 to 0 and 0 to 1. That will be 1's complement of the given number. Usually ask for 1 mark. If they give it in binary form and they ask is to write in 1's complement, then it's 1 mark. Otherwise, if it is given in decimal and if it is asked to write in 1's complement, it can be asked for 2 mark or 3 marks. One more simple example we shall take. Sum 54. One, 2, 4, 8, 16, 32. 32 and 16, 8, 48. 54 minus 48, 6. So 1, 1. 6 will be 4 and 2, 0, 0. Let's cross verify it. 32 plus 16 plus 4 plus 2. 14, 4, 5, 54. Yes, right. 54 to the base 10. So 54 to the base 10 is equal to 1, 1, 0, 1, 1, 0 to the base 2. What next? Write that in 1's complement. 0 to 1 to 0, 1 to 0, 0 to 1, 1 to 0, 1 to 0, 0 to 1. So this is 1's complement of 54. Try some numbers like 73 to the base 10. Find 1's complement of this. 35 to the base 10. Next is 2's complement. 2's complement of a given number. What is 2's complement? 2's complement is like this. First get the 1's complement and add 1 to that 1's complement of the given number, where we need to add to the LSB of 1's complement that we got from the given number. That's why 2's complement is equal to take 1's complement of the given number and add 1 to 1's complement of the given number that we have taken from the given number. Suppose the given number is some 23. Now what to do? First get the number in binary. This is in the base 10. Find, the question may be like this, find 2's complement. Complement of 23. First write this number in binary. So 23 is how much? 1, 2, 4, 8, 16. 16 plus 8 will be 24. No, it's not possible. This will be 20, 22, 23. So 23 to the base 10 is equal to 1, 0, 1, 1, 1 to the base 2. Now get the ones complement. Ones complement is 0, 1, 0, 0, 0, because 1 becomes 0, 0 becomes 1, 1 becomes 0, 1 becomes 0, 1 becomes 0. This is one's complement. In order to get 2's complement, what we should do? We have to add 1 to this. So add 1 to LSB. Just add. 0, 1 is 1. This will be 0, 0, 1, 0. So what is this? This is 2's complement. Two's complement. Number is given. First write that in binary form. Then get 1's complement of the given number. 1 becomes 0, 0 becomes 1. It's easy. Then add 1 to the LSB and add it up. 0 and 1 it will be 1. Then just add it up, write it as it is. So we got the answer which is in 2's complement. (52) to the base 10. Base 10. 52 is how much in binary? Let us see. (32). Next one will be 64. So this is not required. Lesser 52 is lesser than 64. That's why 64 bit is not required. Now 32 plus 16, 8, 48. So these two bits will be 48. 48. Now 4. 48 plus 4 will be 52. So this will be 4. The other values will be 0. Isn't it? That's why write it in binary. It will be 1, 1, 0, 1, 0, 0. Then 1's complement. 1's complement will be 1's complement. This will be 0, 0, 1, 0, 1, 1. Add 1 to this. 1 and 1 will be 0 with the carry 1. 1 and 1 will be 0 with the carry 1. So 1 here, 1 here, 0 and 0 here. So in this case 1 and 1, of course we are going to have that concept next. Binary arithmetic. In that case we will have binary addition, binary subtraction, etc. So for the time being, just remember 1 and 1 will be 0 with the carry 1. That carry 1 and 1 again it's 0 with the carry 1. That 1 is written here, this 1 is already there, then write this. So this will be 2's complement. Don't worry about the binary addition now, because that will be our next topic. So in the next class we shall see about binary arithmetic. Thank you.